Hi everyone. We are going to go through this. I don't have a calculator on me at this moment, so I'll do this in a couple of phases, and if I need a calculator, I'll come back to the ones I need a calculator for in the next video. Now, for 1 and 2, determine the measures of two coterminal angles, one negative and one positive, for the angles given. If it is in degrees, let's answer it in degrees. If it's in radians, let's answer it in radians with pi as the answer, as a part of the answer rather than, or in terms of pi, I should say. So, negative 87 degrees. I like to get just a visual of that to start out with. And if I go here, I'm at negative 90 degrees. So I'm starting with this as the initial side. And if I go really close to the y-axis here, this is negative 87 degrees. Now, if I were to go that same direction, the negative direction, around starting here and coming around and going again, that is the negative 87 degrees minus 360 degrees. The negative 360 is around once and then negative 87 again. And when I look at that, it's, let's see, negative 447 degrees. That's a negative. Now for the positive, I would want to go in this direction. And here I know I'm at 270. And I'm 3 degrees short here, so if I add 3 more degrees, I get 273 degrees. And you could get that negative 87 plus 360, I believe, would give you that answer. Now on number 2, 7 pi over 18. If I subtract 2 pi from that, I'll get it, and if I add 2 pi to that. Now, 2 pi in this case, I'm going to make it in terms of 18ths, would be 36 pi over 18. So if I take the 7 pi over 18 and I subtract 2 pi from that, which is 36 pi over 18, I get negative 29 pi over 18. So there's a negative answer. And if I take the 7 pi over 18 and I just go around again from there and add 2 pi or 36 pi over 18, I have 43 pi over 18 for my positive answer. All right, complement. Sum 90 degrees. Or pi over 2, and supplement, the sum of two supplementary angles is 180 degrees, or pi. So we'll use degrees here, we'll use radians here. So I'm going to take 90 degrees for the complement, 90 degrees minus 37 degrees, and get 53 degrees. For the supplement, I'm going to take 180 degrees minus 37 degrees and get 143 degrees. For the complement on this one, I'm going to take pi over 2 minus pi over 12, which is pi over 2 is the same as 6 pi over 12 minus 1 pi over 12. Which is 5 pi over 12. And for the supplement, I'm going to take pi minus pi over 12. I didn't mean to write that fraction bar. And that is, pi is 12 pi over 12 minus 1 pi over 12. And that gives me 11 pi over 12. Okay. Now, I'm going to convert negative 210 degrees to radians. So I have negative 210 degrees. And I want it to cancel out with the degrees here. So pi radians is equal to 180 degrees. So I'm essentially just multiplying this thing by 1. So I got negative 210 pi over 180, 21 over 18. 3 is divisible. That's negative 7 pi over 6. And number 6, if I convert that to degrees, I got 5 pi over 6 radians. If I multiply that by 180 degrees over pi, then the pi's cancel out there. And I'm going to do a little bit with this. This is 6. Divide by 6 here and divide by 6 here, and you get 30 degrees. And 5 times 30 is 150 degrees. Okay. I think I probably need to save these next two for the next video. And number 9. I'm going to go to number 10. When I have a calculator handy, I'll come back to those. Number 10, it says find the exact length. So if they want that in terms of pi, I think I'll be in pretty good shape. The exact length is arc length is the radius times the theta in degrees. You know, it just happens to be, now we can do the conversion, but 150 degrees that we just did is the same as 5 pi over 6. So theta is 5 pi over 6. The radius is 19. So my arc length, in exact terms, where we don't multiply by pi because pi is an irrational number, 19 times 5, that's 95 pi over 6, and the units are feet. It's the length of this arc. I'll save 11. I will do 12, but I'm going to actually, I'll skip 13 for now, but find the angular speed in radians per minute. We have a carousel with a 50-foot diameter making 4 revolutions per minute. So 4 revolutions per minute, and the conversion, you have 2 pi, one complete trip around, one complete revolution is 2 pi radians. So 2 pi radians per one revolution. And that's what I'm going to multiply this by, because my revolutions will cancel out when I do that. So it's 2 pi, no fraction, radians per revolution. And the revolutions will cancel out, and we're looking at 8 pi radians per minute. And it doesn't tell me to round to the nearest hundredth or anything, so I'm not going to multiply that out. I'm just going to leave it in that form. Okay, I'm going to skip 13 because I do need to do some calculations on that one. Number 14, sketch a right triangle corresponding to cotangent of theta equals 7 over 2. All right, well, cotangent, tangent is the opposite side over the adjacent side. I never think much about cotangent, but it is the reciprocal of that. It's the adjacent side over the opposite side. So if I draw, these are the 2 legs then of the right triangle. With tangent and cotangent, you're getting your the 2 legs. So if I draw this triangle here and make this 7 and this 2, then my theta, the angle, needs to be, the 2 needs to be the opposite side. So I've got theta up here, and the adjacent side is 7. Whoops. It's not opposite over adjacent, it's adjacent over opposite. So let me just change that by putting theta right there. So the other trig functions. Sketch the right triangle, now find the other trig functions. sine is opposite over hypotenuse, which I don't know just yet. 2 squared plus 7 squared equals your hypotenuse squared, which is 4 plus 49 c squared, 53. C is going to be the square root of 53. So I didn't completely finish my triangle before I started. The sine of theta is opposite 7 over hypotenuse, square root of 53. And I'm not done. Let's rationalize the denominator. And I have 7 radical 53 over 53, sine of theta. Got it. Cosine of theta is adjacent over hypotenuse, so it's 2 over square root of 53. And if I rationalize the denominator again, I'm going to have 2 radical 53 over 53. I didn't show that this time. Sine, cosine, tangent of theta would be the reciprocal of cotangent, but it's opposite over adjacent. Oh, for crying out loud. Okay. I had this right the first time, didn't I? Okay, I'm going to back up a little bit here. Try to salvage something here. So theta is here. That's 2 over 7 is the tangent. Okay, but I'm going to make a quick adjustment here. The sine is, where's my theta? Okay, let's get the right theta here. I was right the first time. The sine is opposite over hypotenuse, so it's 2 over radical 53. So let me just, my quick adjustment, the sine of theta is this, and cosine is adjacent over hypotenuse. So cosine of theta is this. All right, we save it. That's tangent, cosine, sine, tangent, cotangent we already know. We need cosecant of theta, which is the reciprocal of sine of theta. I don't want to mess with this. Let's do it right here. That's the square root of 53 over 2. And then the secant of theta is hypotenuse over adjacent, which is the square root of 53 over 7. Okay. I had to kind of go ahead and adjust after I got things straightened out there. All right, I will work on another video with this and post it also. All right, take care. Bye-bye.